NASA reports that Voyager 1 is finally talking to Earth again, sending back usable information. But beneath that simple headline lies a reality that is far darker and much more complex. The most remote human-made object in existence began transmitting data that defied all interpretation. It wasn't just silence out there. It was chaos. For weeks, the signals arriving were fragmented and disordered, completely devoid of any readable telemetry. To the naked eye, it looked like a hardware malfunction, the death rattle of a machine that has been traveling for nearly 50 years. But as engineers stripped away the layers of static, they realized something profound was taking place. Voyager hadn't simply broken. It had crossed a threshold into the unknown. We once believed the edge of our solar system was a distinct, clean line. We were mistaken. Voyager has entered a region so chaotic that even NASA was left stunned. What the probe discovered out there is rewriting our understanding of what the edge of space can be. What if the boundary of our solar system isn't an end, but the beginning of something stranger? We are decoding a message from 15 billion miles away. We are going to examine the glitch that nearly ended the mission, the impossible repair, and the terrifyingly beautiful things this little tin has witnessed in the dark. To truly grasp why this recent data is so shocking, you have to understand just how close we came to losing Voyager 1 forever. Late in 2023, the probe stopped making sense. Instead of clear data, it began beaming back zeros and ones arranged in patterns that fit nothing we knew. Imagine getting a text from a friend, but instead of words, it's just a random string of emojis and gibberish. That is exactly what NASA was staring at. Initial diagnostics pointed to a hardware malfunction, but deeper analysis identified a more serious anomaly, a corrupted memory section within the spacecraft's flight data subsystem. This wasn't merely a software bug. A single onboard chip, no larger than a human fingernail, had likely been pierced by cosmic radiation. Out there, with no atmosphere to shield them, spacecraft are bombarded by high-energy particles that can tear through circuitry and flip bits in memory. It's like static on a cosmic scale, but with fatal consequences. The instructions Voyager once stored were either scrambled or lost entirely. The system was operational, but it was speaking a language no one understood. The engineers at NASA's Jet Propulsion Lab were essentially staring at a ghost. The only solution required reprogramming the main functions of the primary data system from over 15 billion miles away. This was an operation never intended to be possible. Remember, this is 1970s technology. Voyager 1 operates on less than 70 kilobytes of memory. That is smaller than the size of a single email header today. There were no backup systems, no alternate processors, and absolutely no protocols for remote intervention at this scale. The team had to manually translate every line of code into raw binary, assign it to new memory locations, and transmit it in fragments. And here is the kicker. Every transmission took 22 hours to arrive and another 22 hours to get a response. A single miscalculation could result in permanent failure. After weeks of silence and trial execution, a new signal finally pierced the void. The data was clean, structured, and interpretable. Voyager 1 had successfully reinitialized its system, recovering from a critical failure using remote instructions executed with zero margin for error. It performed a system-level procedure no spacecraft in history had ever been designed to attempt, and it worked. The fact that Voyager is even alive to experience a glitch is a miracle in itself. This is the record of a mission that was never supposed to survive. It began in 1977 with a launch never meant to last more than 5 years. In 1977, two nearly identical spacecraft were quietly prepared at Cape Canaveral, Voyager 1 and Voyager 2. These twins were built with less mathematical power than a pocket calculator. The mission was ambitious but expected to be brief. Observe the outer planets, take some photos, and conclude the assignment. The entire trajectory of this mission hinged on a stroke of cosmic luck. It relied on a rare planetary alignment, an orbital structure that occurs only once every 176 years. This timing allowed the spacecraft to utilize gravitational assists, slinging from one gas giant to the next, dramatically reducing travel time. NASA recognized this narrow window of opportunity and acted, knowing that survival beyond Saturn was considered unlikely. Because they were traveling so far from the Sun, solar panels were useless. Instead, each probe relied on a radioisotope thermoelectric generator, essentially a nuclear battery that converts heat from radioactive decay into electricity. It provides a slow, steady trickle of power that can last for decades. Voyager 2 actually launched first on August 20th, 1977, followed by Voyager 1 16 days later. But despite launching second, Voyager 1 traveled faster, overtaking its twin shortly after deployment. They were racing toward a darkness they weren't built to endure. They had no artificial intelligence and no backup CPUs. They were just metal boxes thrown into the abyss. And yet they functioned. When Voyager 1 reached Jupiter in 1979, the images it sent back changed astronomy forever. It didn't just see a gas giant, it saw a monster. Jupiter was revealed to be a powerful, dangerous world surrounded by radiation so intense it could cripple spacecraft within hours. But Voyager 1 made it through and delivered discoveries that shocked the world. It detected massive magnetic fields, faint rings, and plasma waves never seen before. Then it spotted something on one of Jupiter's moons, Io. Io was thought to be a dead, frozen rock. Instead, Voyager saw it was covered in active volcanoes, some erupting with such force they sent molten material hundreds of kilometers into space. The probe then moved to Saturn, where the surprises continued. Scientists knew about the rings, but Voyager revealed they were braided, full of strange gaps, and shaped by hidden moons. And then there was Titan, Saturn's largest moon. Voyager discovered that Titan wasn't just a rock. It had an atmosphere, a thick orange haze wrapped around it. This haze was filled with organic chemicals, leading some scientists to believe it could be similar to what Earth looked like in its early years. It is the most comparable place to early Earth in our entire solar system. Voyager couldn't see through the haze, but it left us with a clue that something important was waiting there. After Saturn, the twins split up. Voyager 1 redirected itself toward interstellar space, while Voyager 2 pursued a longer trajectory to the ice giants. In January 1986, 2 years after its expiration date, Voyager 2 arrived at Uranus. To this day, Voyager 2 remains the only spacecraft to have visited this distant planet up close. What it found was bizarre. Uranus wasn't upright. It was tilted almost completely on its side, spinning like a rolling ball. Its magnetic field was twisted and tilted, completely defying former models. It documented 10 previously unknown moons and a set of thin, dark rings that were almost invisible. Then came the final stop, Neptune, in 1989. Far from being a frozen, dead world, Neptune was violet. The winds there moved faster than the speed of sound. Massive storms larger than the entire Earth spun across the surface. As it passed Neptune's largest moon, Triton, Voyager gathered data that overturned long-standing assumptions. Triton was covered in frozen nitrogen, with geysers spraying liquid nitrogen into the air that froze before hitting the ground. The surface looked young with few impact craters, suggesting ongoing geological activity. The information from Uranus and Neptune wasn't just new. It was the last humans have ever gotten. No other mission has gone back since. Everything we know about the edge of our planetary neighborhood comes from these brief flybys. But eventually, the planets ran out. There was no next stop. Voyager 1 had passed Neptune's orbit and just kept going, heading for nothing. But nothing turned out to be the most interesting part of the mission. Because the edge of the solar system isn't a clean line. It's messy, it's strange, and no one had ever actually seen it before. That edge is called the heliosphere. Imagine it like a giant invisible bubble blown outward by the solar wind. Those streams of charged particles constantly pouring off the sun. The solar wind travels fast and far, but eventually It hits the stuff between the stars, the interstellar medium. And that medium, made of gas, dust, and magnetic fields, pushes back. That clash creates the edge, and Voyager 1 was about to crash right into it. Scientists had long theorized about what that boundary might look like. Would it be a soft gradient, a hard wall? Most models were just best guesses based on computer simulations. For years, they weren't sure when or even if the spacecraft would cross that threshold. But in 2012, the readings started to shift. Plasma density spiked. Magnetic fields changed direction. Charged particles from the sun disappeared. And just like that, Voyager 1 was outside. It became the first human-made object to leave the solar system. 6 years later, Voyager 2 did the same. But here is the mystery. They didn't find the same things. Even though both spacecraft exited the same solar system, their data didn't line up. Voyager 1 entered a region where interstellar particles were dense and compact, almost like hitting a wall of energy. But Voyager 2 found something different. It found a leak, a long, stretched-out flow of particles reaching over 150 million kilometers into the void. Same exit, two totally different doors. And there was another surprise. Voyager 2 still had a working plasma sensor, and what it saw made scientists pause. The plasma beyond the solar system was hotter than expected, almost 30,000 degrees Celsius. But because the medium was so thin and spread out, it didn't burn the probe. It just floated through it like a submarine through warm fog. Both Voyagers also recorded something else that nobody had predicted. The edge of the heliosphere wasn't smooth. It wasn't a perfect shell. It was wrinkled. The data revealed giant folds in space billions of kilometers wide. These ripples are caused by waves of solar energy pushing and pulling at the bubble's edge like the tide crashing against the shoreline. These folds move and shift. In some places, the edge of the solar system actually chased the probes as they tried to leave. What should have been an empty, quiet crossing turned out to be a noisy, chaotic mess. Everything scientists had modeled was wrong. Everything they thought they knew about the shape of our home in the galaxy was shattered. The solar system isn't a static sphere. It is a breathing, distorted shape fighting against the pressure of the galaxy. And the deeper the probes went, the stranger it became. But Voyager isn't just a scientific tool. It is also an ambassador. Long before it left the solar system, before it skimmed past Saturn or entered the interstellar deep, engineers attached something strange to its frame. It wasn't a sensor or a camera. It was a 12-inch golden record attached to the side of the spacecraft like a quiet signature. This wasn't science. It was art. It was a message, not for us, but for them. The idea came from Carl Sagan, who assembled a team to capture the essence of Earth. They had only a few months to decide how to represent the entire human species on a single disk. It wasn't just music or greetings. They included diagrams of DNA, recordings of a heartbeat, and a stylized map showing our location in the galaxy using pulsars as coordinates. It was humanity's greatest mixtape sent to no one from everyone. The chance of another civilization discovering a small metal disk in the infinite dark is close to zero. But the point was never practicality. It was symbolism. It was a declaration that we existed, that we were capable of thought, language, and music. Even if it is never found, it will drift untouched for millions of years long after Earth is gone. It wasn't a transmission. It was a whisper to the silence. Right now, as you watch this, both Voyagers are still out there. They're still floating through space, still awake, and still whispering back to Earth across billions of kilometers. It is easy to forget that these two spacecraft, built in the 1970s and running on technology older than the internet, are farther from us than anything else we have ever made. Voyager 1 is currently over 13 billion miles away. That is more than 24 billion kilometers from the Sun. Voyager 2 isn't far behind. The distance is so vast that light itself struggles to keep up. Every command sent from Earth takes 22 hours to arrive, and every response takes another 22 hours to return. Every second, they move a little deeper into the unknown. There is no destination. There is no way to turn around. Just an endless drift into silence. But that silence doesn't mean stillness. The data is still coming. It's slower now and less often, but it is still very real. However, there's a cost to this journey. The Voyagers are dying. Each spacecraft runs on radioisotope thermoelectric generators, RTGs. These are nuclear batteries that convert heat from radioactive decay into electricity. But like all nuclear material, the fuel decays. They lose a little bit of juice every single year. To keep the mission alive, NASA has been forced to make heartbreaking choices. They have been slowly shutting down instruments one by one to preserve power. It is a process of triage. They turn off a heater here, a camera there, just to keep the heart of the ship beating for a few more months. The engineers predict that at some point in the 2030s, the power will finally drop too low. The remaining instruments will turn off, the antenna will fall silent, and the Voyagers will go dark. Before that darkness comes, the probes are giving us one last look at the universe. Even in their compromised state, they are detecting things we never imagined. Voyager 2 still has a working plasma instrument, giving scientists fresh readings on the temperature, density, and speed of the interstellar medium. Voyager 1, though missing that sensor, is still providing magnetic field data. And most haunting of all, Voyager 1 is picking up plasma waves. These are vibrations in the gas between stars that hum in the background of deep space. The data from the two probes is telling us something critical. Space isn't the same everywhere. Because the two spacecraft ended up in slightly different parts of the interstellar region, they're seeing different things. When one probe detects a change in pressure or magnetic fields, and the other doesn't, it reveals the hidden structure of the galaxy. This is the twilight of the mission. By the time they finally go dark, they will have traveled over 20 billion kilometers. They will have seen more than any machine ever has. But even when the batteries die, the journey won't stop. Newton's laws of physics guarantee it. They will keep coasting through space for thousands, maybe millions of years. They will become silent, invisible artifacts. Two small metal boxes drifting between the stars, carrying their golden records. The sounds of Earth's oceans, the voices of our children, and the music of our cultures into whatever lies beyond. They are no longer just explorers. They are time capsules. Maybe someday someone will find them, maybe not. But they are out there now, and they belong to the stars. By the time they finally go dark, they will have traveled over 20 billion kilometers. They will have carried our history, our biology, and our art further than any human will ever go. But there is one last thought that keeps the engineers at NASA awake at night. Everyone who studied the signals, everyone who tracked the strange shifts or listened to the ghostly sound of space, eventually agrees on one unsettling thing. The Voyagers weren't just drifting unnoticed into the void. The sudden data glitches, the corrupted memories that needed to be rewritten, the strange shapes at the edge of the solar system. It almost feels like a reaction, like we knocked on a door we couldn't see. The data suggests that something was out there watching, waiting, and when our little machines got close enough, it reached back. What do you think? Was the glitch just cosmic radiation, or was it a sign of something else living in the dark? Let me know in the comments below. And if you want to keep exploring the universe with us, make sure to hit that subscribe button and turn on notifications. The universe is full of secrets, and we are just getting started. Thanks for watching. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.